Hello and welcome to another episode of Global Science. I'm Lev Horodisky.
And I'm Fabia Battistuzzi.
So the question for today, Fabia, have you ever been to a museum?
Yes, probably way too long ago. And the last museum I went to was an arts museum, which was very interesting, but that's not what we're talking about in this science-based podcast.
Why not?
Well, we could talk about arts, but we are more interested in science. And so have you ever been to a science museum, Lev?
Of course I have. I just can't remember when. I think I got dragged to one with my nephew, and it was mostly watching him run around, pulling knobs and spinning things, and then trying to figure out where he went and hunting him down. So I think that's my last memory of a science museum.
Just admit it, you lost your nephew because you were playing with all the exhibits, and that's why you didn't know where your nephew went, because the exhibits were too cool.
I will make no comment on that.
Well, see, that's the whole point. Museums are really fun because there are all these crazy exhibits that are extremely interactive now. And we just walking through the exhibits, you observe them, you play with them, but you don't necessarily know how they're actually built and who makes those exhibits.
So are we going to get any insight on that, actually?
I think we are, because we have our guest today, Dr. Daniel Hammer. He's an assistant professor of geology at Southern Illinois University at Carbondale. And Dr. Hammer is a long-standing friend of ours. We were in grad school together. And he has been involved in some museum exhibits on top of his usual duties as a faculty member with teaching and research. And so, Dr. Hammer, do you want to tell us a little bit more about what is your daily life?
Hi there. Well, it's great to be with you folks today. I
Wonderful.
have not seen you for a while, especially during this pandemic, right? We've not.
Yep.
Yeah.
Not going much of anywhere.
This podcast is mostly an excuse for us to talk to our friends again. Hopefully others will find it interesting.
Well, it's great to be here. Yes, my name is Daniel Hammer, and I'm an assistant professor of geology. I'm a geochemist and mineralogist. And my research focuses on how minerals form. So when we say how minerals form, there's a lot of different ways that minerals form, and they form all across space and time. But I'm trying to figure out exactly what conditions cause which minerals to form, and I'm doing that both in kind of a very local, very small scale sense of doing actual experiments in the lab of crystallizing minerals and finding out how that happens. And also, at what point in Earth's history did different types of minerals form or go away? Mm-hmm. Because it turns out, in the beginning in geology, we kind of, we take a look at what's there, on the Earth and in the Earth. And we kind of have this presumption that the things that are changing are just up here on the surface. Life is changing, weather is changing. We know those things because we see them all the time. But we tend to think of rocks as just being boring, static objects under our feet that are just kind of sitting there and not doing much of anything. And it turns out that's very false. Both in short and long time scales, they are constantly changing and forming new things. And the more we realize that, the more that we need to figure out, the history of the Earth in terms of what the Earth is actually composed of and how that's changed over time.
So how did you get into mineralogy? Because I know you are a total mineral nerd, because your car was called the Mineral Mobile, and not just because it was covered in rust.
That's right. It did have a copious dose of iron minerals. I do remember that. Yes, it was called that because my nickname in college was Mineral Boy, as a matter of fact.
Why is that? I know some horror stories you've told us about Thanksgivings past that went catastrophically wrong.
Well, I was, from a relatively early age, I was really into chemistry. And I'm still into chemistry, and chemistry still, plays a pretty large role in what I do. And then round about the beginning of high school, I was in an extracurricular event called Science Olympiad. And maybe some of the listeners out there will be familiar with Science Olympiad. It's a great program for middle schoolers and high schoolers. And I got into Science Olympiad, and my coach put me in a couple of chemistry events because she knew I loved chemistry. She also put me in an event called Rocks and Minerals. And people who know me nowadays will be horrified to hear this, but I hated the event Rocks and Minerals. I know that sounds bizarre,
not
doesn't
possible then.
That sounds like the origin story of like a supervillain.
But, as I dug into it, I realized that all the differences between these minerals could be explained through their chemistry.
Oh, I see what you did there with the pun.
Did I make a pun? I didn't.
You did, yes. You dug into things.
Oh, good for me. Okay. I'm always making geology puns. I do that to my students a lot too. So yes, so once I got into it, I realized that, this was something that could readily be explained by chemistry. And so I got really into the chemistry of minerals. And I've been doing that ever since.
Excellent. So then, have you ever been to a museum?
Well, yes, I've been to.
This is a real in-depth podcast here with really.
I know.
Really
I was not prepared
questions.
for these hard-hitting questions, Lev. But yes, I especially love science museums and natural history museums.
So have you ever been involved in museums in any other way except for being an audience member?
Yes. So I recently, just over the past couple of years, I was involved in helping to create an exhibit at the American Museum of Natural History in New York City.
Well, that's exciting.
Yes. So this is, I can tell you a little bit about it. This exhibit is part of the newly redesigned Allison and Roberto Mignon Hall of Gems and Minerals. It's a brand new renovation, so it's a new part of the museum. And a portion of it is dedicated to the evolution of minerals. So as I was mentioning just a minute ago, we now know from looking at really big data sets of where minerals occur on Earth and what their ages are, we have pieced together that mineralogy has changed a lot over Earth's history. Different minerals have come into being at different times in the past. And now that we've reconstructed more of that and we understand it better, we want to share this with the public. So I was a scientific advisor and I helped advise on some of the content for this new exhibit that shows how minerals changed through time.
So I'm curious, how did you get involved in this? Because it's not necessarily something that happens to all faculty, right?
No, this was a really cool opportunity. And the way that I got involved was the curator of that portion of the museum contacted me, sent me a message and said, I've seen the work that you've done and published on mineral evolution. My very last postdoc was with kind of the father of this new line of research. This line of research is only 10 or 12 years old or so. And it was pioneered by a mineralogist at the Carnegie Institution by the name of Bob Hazen. And I was a postdoc of his right before I got my faculty position at SIU. And so the people at the museum had been following this work and saw that I was involved, and they reached out to me and asked if I wanted to be involved in helping design the exhibit.
That's quite impressive.
How long did the whole process take to design from the initial email to when it finally debuted? Because I remember reading about it. I think you may have posted it to Facebook. I thought, this is really cool. I had no idea you were involved in designing a museum exhibit. So how long did the whole process take?
Yeah, I'd say the whole process took about a year and a half. You wouldn't think that it would take that long to design something like that, but of course, for one thing, I, and as well as the rest of the design team at AMNH, we're working on this in parallel with lots of other things, and especially, of course, faculty are teaching and doing other lines of research and going to faculty meetings and so forth. All of that is going on, and I'm doing this, just a little bit at a time. But also, it turns out and this is one thing that I don't think, a lot of visitors of museums realize, because it kind of looks like just a bunch of stuff thrown on the wall. But there is a lot of careful thought and a lot of careful design work that goes into designing these exhibits. A lot of people are thinking very carefully about how to present this in the most understandable way and visualize things in the clearest way that they can. So, there's lots of just brainstorming ideas and writing them all down and discussing them all through over and over again, and then before you finally settle on one way to do it.
So did you have to interact a lot with, for example, artists and other individuals that don't necessarily have the scientific experience, but they have the public experience and the artistic experience to kind of fuse together the two sides of a story, which is the scientific side and the humanity kind of story?
Yes, yeah, I very much did. And that was one of the really fun parts of the process is, I was working with, a couple of other, fellow scientists who understood the science behind it, but I was also working with science writers that specialize just in science communication. I was working with a team of artists and designers that were hired from an outside company. I was, working with exhibit managers. I was working alongside all of these people to help create the best exhibit that we could. And it was really fun to see the different iterations of it and what was coming out from the art department and kind of see it take shape over time.
And that's interesting. So if someone's getting into this for the first time, what would you recommend? Because I'm working with one of my students, we're working with the Virgin Islands Children's Museum to try to develop some astronomy related materials. The Children's Museum, I think, is quite different from a regular science museum where it's more displaying a story to tell, whereas I think my impression of a children's museum is that it's supposed to be more hands-on and exploratory. Do you have like recommendations for if you're starting on this kind of work? What struck you as most interesting and most different from what you had been prepared for?
Mm-hmm. Yeah, in terms of kind of like this direction of thought and this direction of research?
Yeah.
Yeah, so I think what really drew me to this and what was really different, than what most of the rest of geology researchers are doing is to approach this aspect of the earth, the minerals that make up the earth, and approach it less like just, an exercise in lab analysis and, in material science, and more like a story. Because so much of what goes on the earth can actually be told in the form of a story. But certain things, like rocks and minerals, we don't tend to tell as a story. We tend to just tell it, well, there's this type of rock and this type of rock and this type of rock. But this new field of mineral evolution, I think, really makes, my discipline of mineralogy come alive in a sense to the public in a way that it hasn't really before, because we actually have enough data now to tell this story of how the earth started, what it was made from at the beginning, and then how that changed over time, and tell it more like a story, more along the lines of the way that we tell the story of how life evolved.
So what is the story of mineral evolution? Because I remember first hearing it at an astrobiology conference of all places, I think in 2008. And when I heard it, it made so much sense to me that I was surprised that no one had really thought of this before or had framed minerals in this kind of framework. So what is that story for people who may not be familiar with mineralogy or geology or potentially science at all?
Mm-hmm. Yeah, so it's a really fascinating story. So it turns out that, when the universe got started, of course, it was just super hot gas, flying and expanding everywhere after the Big Bang. So the very beginning of the universe, there were no minerals, because minerals are defined as being, solid and crystalline. But then over time, stars formed, and around the edges of the stars, in the atmospheres of those stars, gases condensed enough, and one of the first elements that condensed was carbon. So it turns out one of the very first minerals in the universe was diamond, of all things. We think of diamond as being these beautiful things that, that only happen deep in the earth. They take lots and lots of pressure. But as it turns out, they can happen in really, really, really low pressure as well. And they were one of the first minerals in the universe.
Oh, bling, bling, bling.
Yeah.
I'm good with that. I can go to space and collect some diamonds. I'll volunteer.
Yeah, so you can picture, little, sparkly, literally little diamonds floating around the edges of stars. And that was some of the first minerals that we had in the universe. Well, then, of course, the planets formed, the material, swirling around the sun coalesced, and it formed the planets. And as soon as we had enough pressure to squeeze all of this solid material together, then we got a whole new set of materials. And we got things like olivine and pyroxene and feldspars. And these are the names of mineral groups that geologists know about, but we didn't really know exactly when they got started. Well, now we have a better handle on it. It was when, asteroids and planets were very first forming. Well, and then from there, you can actually step through a series. It tends to happen in jumps. Like, for example, if you've ever looked at the evolution of life, you know that there's this theory called punctuated equilibrium, where things don't change slowly over time. They tend to stay static for a while, and then there are periods where they change a whole lot. Things suddenly jump from one state to another state. Well, the same thing happens in mineral evolution, as it turns out. There are certain key events in Earth's history that that really filled the earth with a lot of new minerals that it had not seen before. And examples of some of these important events are the formation of the oceans, the start of plate tectonics. And of course, plate tectonics is the whole reason that we have mountains and earthquakes and our different continents. So that was a major force that shaped the earth, and it also generated new minerals, lots of new minerals actually. Another key event, one of the biggest events actually that tripled, I kid you not, according to all the data that we have, tripled the number of minerals on Earth, was the very first photosynthesis. The bacteria in the ocean that performed the first photosynthesis, and by doing that photosynthesis, put the very first oxygen in the atmosphere.
I just love it how biologists at the end of the day always come into the picture.
They come in after the geologists.
Yeah.
I'm fine.
Right. Well, I guess, listeners know that Fabia is a biologist, right?
Yeah. Well, it depends if they have heard our episodes or not.
But yeah, there's this really beautiful interplay where the evolution of life and the evolution of minerals, didn't take place separately. They influenced each other, and they've been influencing each other ever since there was life. So as it turns out, life is what put oxygen in the atmosphere, and that reacted with all the minerals on Earth's surface. It created a bunch of new minerals. It created thousands, actually, of new mineral species that the world had never seen before. And then from that point forward, as minerals evolved, then new life forms that were living near them in new chemical environments were able to evolve in new ways. And then they, in turn, changed the environment enough to create the possibility of new mineral species, and on and on. And so it kind of reacted that way in kind of a feedback loop, where one was always affecting the other.
I really like that story because it kind of ties in the biology of the planet with the geology of the planet in a really intimate and ongoing way. So what's the newest mineral? Would you count like a circuit board as a type of mineral, or does a mineral need to be a certain have certain characteristics? Is anything that humans create? I mean, we certainly create new chemical environments that allow new minerals to form, but are there things that we deliberately create that you would consider a mineral, or not quite as much?
That's a great question. And actually, mineralogists in recent years have been arguing about exactly topics like this. But generally, we require that a mineral be something that forms through natural processes. And we have been allowing more and more things that form, for example, in mine dumps. So there was human action involved, but not purposeful human action. So if you have a mine dump where humans have dug up things and exposed it to the atmosphere, and then reactions happen and you get a new mineral, then that can count, because it is primarily natural processes acting on natural materials that did that. But we do not allow things that human beings make in the lab on purpose.
It sounds a little bit similar to the distinction that in biology we make with synthetic life. We still call it life, but we make sure that we put the word synthetic in front of it because it's created in the lab, even though many of the processes involved are similar to what happens actually in the real world, but it's very heavily human directed. And so it's always interesting to me to see how many parallels there are between the different sciences, and especially between biology and geology. A lot of the processes really seem to be quite similar.
Yeah, they really are. Now, I have to ask Fabia, have you ever created synthetic life?
Not that I know of. Now, I don't guarantee what happens behind the scenes in my lab, but I don't think so.
And if anybody you know has, does it have access to our nuclear launch codes?
Well, I cannot divulge that kind of information,
Okay.
Hey, what happens in the lab stays in the lab.
Exactly. Kind of like Vegas.
Yeah, you're absolutely right, Fabi. I think there's a lot of interesting parallels. And that's something that we tried to highlight in this exhibit at AMNH, that all of these processes amongst living and non-living things are always affecting each other, and has kind of, made the present day state of the earth really unique.
So is the exhibit open, and have you gotten feedback from audience members that may have gone through the exhibit? Like what does the exhibit actually look like? Are there things for them to do, or is it mostly like reading and looking at things?
Yeah, so there's two parts to the exhibit. There is an exhibit that shows a timeline of mineral evolution, and it's a spiral timeline. So the Big Bang is at the very center, and then it spirals outward, and there's a color-coded series of different stages, and it shows you what kinds of things. And the fun thing is we actually have examples of samples of those minerals. We've got beautiful samples of the minerals that were actually forming at those different stages embedded in the timeline. And there is a little bit of an explanation of each one of those stages and what was happening in the earth at that time that was generating new minerals. So that's a fun part of the display. And then adjacent to that, we have a video. We made a video that kind of tells this story of the earth from the mineral perspective, and how it interacted with life, that you can kind of watch and help visualize even better.
And is it open to the public yet? And have people given you feedback on it?
Yes. So it opened to the public last June, in June of 2021. It opened almost a year behind schedule because of the pandemic. Sadly, we were planning on a 2020 opening, and it wound up being summer of 2021. But yes, it is open to the public now. Has been for a few months now, and I do have a few friends who have been able to visit, and they really like it. They said it's really exciting to see this perspective, and the rest of the Gem and Mineral Hall is also beautiful. They've got geodes and crystals and meteorites and all kinds of things on display from all different areas of earth science. Some of the samples are bigger than you are.
Wow.
So Yeah, so it's a really fantastic display, and if anybody in New York or visiting New York is interested, I very much encourage you to see it. There's a lot of new things in that renovation to see.
Sounds like it's time to plan a trip.
Yes, and you know what? So this is embarrassing to admit on your podcast. I have not been to it yet. I helped design it, but I've not been to it yet. But I had a baby, and it's been a pandemic, and travel has been difficult. So that's why I haven't
got
done
a lot
that.
on your plate.
I do. There's a lot on my plate, but I very much hope in the near future that I will be able to go over there and visit the great folks that I work with at the museum, and see the completed version of the exhibit. I've seen photos of it, but I've not seen the entire completed exhibit yet.
Is this a permanent exhibit or a time-limited exhibit?
It's a permanent exhibit, thankfully. So it will probably be around for about 20 to 25 years or so, until they make a decision to redesign that portion of the museum.
And has the exhibit generated its own new minerals?
Unfortunately, we don't think so.
Well, not yet.
But you never know. New Yorkers, step on all kinds of weird things on the street out there. And if they tramps into the museum and, track it in, and the wrong things react with each other, we could very well have new minerals on our hands. You never know.
All right. I think that is a great place to leave off. Thanks for joining us, Dan. This was fantastic.
Yes, thank you so much. It was a pleasure to be here.
So, Fabia, what did you learn about minerals?
That I very much need to go to New York right now so that I can see this awesome exhibit. And I was actually thinking of going this summer, so I think I know what I'm going to do first.
Hopefully this podcast comes out before the summer. Otherwise, it'll sound like you're not going until 2023 or 2024.
That is a good point, but wherever I have the time, that's where I want to go and learn some mineral history.
So do you think you would end up getting interested in museums? Because I've already started getting into some of the museum work down at the down in the Virgin Islands with some of my projects, because it's an interesting, I think, opportunity to do informal education. What about you?
Honestly, I think I would love to do something like that. It would be a very different experience. And I kept thinking as Dan was talking, what kind of skills are necessary to be able to participate in an experience like this, that we as a faculty, or in general, people that work in academia, develop. And one of the things that we do a lot is, outreach. I often go to either high schools or elementary schools to talk to kids about, evolution, which is the subject that I study. And so I think, you can sort of repurpose those skills in a different way. But I think it would be really exciting to be able to just, visualize, see in real life some concepts that are constantly in our heads only.
So what would you design an exhibit about?
For me, actually, it would be something kind of similar to what Dan did, but from the life perspective. I work on the evolution of life, and I'm very interested in the very beginnings of life, especially, the first couple of billions of years of evolution, and just help people see how different our planet was before, for example, oxygen, like Dan talked about. It just looked different because at some point we didn't have continents on it, and if we had them, they were in different positions, and so the life that was on it was also very, very different. And so I would love to be able to do something like that.
Yeah, I think you're just looking for an excuse to buy all those giant plushy microbes.
Well, yes, and I kind of have the plan of making a giant exhibit of plushy microbes in my lab. So, that's beside the point.
Oh. Yeah, all right. So anything else you learned that was interesting?
Well, I think I have learned that I need to see if Dan can give a talk at my university. So at some point, Dan, I will be in touch with you because I think it would be very cool for us to interact a little bit more. But no, what I really hope is that these kind of conversations can inspire anybody who's listening, students, or even anybody that currently has a career but is looking for a new challenge, to think outside the box. Whether you are in academia, whether you are in industry, there is so much more that we can do with the knowledge that we acquire over the years, that in many cases we don't necessarily think about. Before I heard about, this experience that Dan had, I didn't even consider the possibility of doing museum exhibits, but I think it's super cool. So it's a very different way of teaching that actually reaches probably more people than we think. So it's good to have this kind of inspiration.
Yeah, I agree. And I think museums and even thinking beyond museums, thinking about observatories, national parks, and a lot of these other informal science education institutions, they tend to get overlooked when we're thinking about science education, and they especially tend to get overlooked when we talk about technology to bring some of those things to life. So that's definitely one of the ideas we're pursuing through a lot of the projects we're working on at Science Voices to help fill in this technology gap, to help bring new ideas into this informal education sphere.
Yeah, and like you said, you have a student who's starting to build connections with a children's museum, and so it's already wonderful to see that there are students who are interested in being those bridges and kind of connecting the academic, the scientific world with the general public world to bring the knowledge to kids in the case of your student, or to adults in the case of other types of museums. So it's I think it's very exciting. How did your student get interested in that kind of experience?
I think mostly we told her to do it. So we had a longstanding connection between the observatory and the Children's Museum, where they'd historically worked together. So we just decided to rekindle that relationship and see if we could capitalize on it and do something with it, especially because the observatory in the Virgin Islands needs to undergo a lot of renovation before it's really tourist ready. Like things on railings on the roof so that people don't fall off the roof, and things like that. So we need to find a place where we can do some of the public outreach events that we're thinking about, somewhere where we can actually run them. And given that the Children's Museum is right next to the docks, it's really close to where all the cruise ships come in. So it seemed like a good opportunity. So I will have to make her listen to this episode so that she gets some ideas on what she can do.
Yeah, and it's a wonderful way for institutions to reach into the community and help the community build resilience and build new opportunities. Like you said, make sure that there are attractions that are available to tourists in a safe way so they don't fall off roofs. And this way, the community benefits from it beyond just learning, but it's actually, economic benefits and other aspects. So it's a very nice way of integrating science into many different aspects of life.
All right. And I think that's a great place to leave off. And we will see you next time. Bye, everyone.
Thank you for joining us.
The music for this episode is Space Chill Out by Penguin Music from Pixabay.com. The Mineral Evolution exhibit is currently running at the American Museum of Natural History. For more information, go to amnh.org/exhibits/permanent/gems-minerals. Global.Science is a production of Science Voices, a U.S. nonprofit organization. You can learn more about us at www.sciencevoices.org. Read about our mission, and you can also contribute to supporting projects like this.